We're back with another example involving absolute extrema. This time we have a particle moving along the x-axis. Okay, so if you can imagine, let's see, can I get over here somewhere? All right, we have here's our x-axis, our coordinate plane rather, and we've got a particle on there. So let's stick a particle on the coordinate plane. There it is, and that particle is going to move to the left and move to the right, back and forth. For all we know, it's just moving along the x-axis back and forth. Okay, so the question says particle moves along the x-axis. Its position is given by the function r of t, which is equal to t cubed minus 6t squared plus 9t plus 3, and this happens for the interval from 0 to 6. All right, t is from 0 to 6, and the question is, what is the furthest point to the left in which the particle reaches? How far to the left does that particle go during the interval from where t goes from 0 to 6? Okay, so this is a candidate's test. This is an absolute problem. We see the EST suffix right there, and so we can go ahead and we can go with our steps. First step is to find our derivative. So we need r prime of t. We have a polynomial right here, so that's a nice derivative to get. You've probably already done it. You've got 3t squared minus 12t plus 9, and yes, obviously that 3 is going to go to 0. So this is our first derivative. Now we need to find our critical points, which means we need to set this first derivative equal to 0. Okay, so we have a quadratic equal to 0, so your algebra 2 is coming into play here. We know that we want to kind of get a couple of binomials, a product of binomials. But for starters, you're probably looking at this and noticing the common factor of 3, just like I did. So let's pull that 3 out. Yes, all right, so we pull the 3 out. Then we're left with t squared minus 4t plus 3 equal to 0. Okay, and the reason why we pull that 3 out is because now we have a product. We have 3 times t squared minus, and that's equal to 0. Okay, well, that means we can cover them up one at a time. We can cover this one up, we get 3 equals 0. That doesn't happen at all. So this really isn't part of our answer at all. In other words, we can divide both sides by 3, all right, and it goes away. And 0 divided by 3 is still going to just be 0. So that 3 doesn't matter. That's the purpose of what I was just talking about there. So now what we're really looking at is, when does t squared minus 4t plus 3 equal 0? Okay, so we have a quadratic. Leading coefficient is 1, so we're looking for 2 numbers here. 2 numbers which multiply to 3 and add up to negative 4. Well, 2 numbers that multiply to 3 are either going to be 1 and 3 or negative 1 and negative 3. Since the sum of the numbers has to be negative 4, we know that the numbers we're looking for are negative 1 and negative 3. So from your algebra class, that's what we have there, t minus 1 and t minus 3. Now we cover these up one at a time, and we can clearly see that our 2 critical numbers are 1 and 3. Okay, so there's 2 candidates right there, 1 and 3, assuming that they're within the interval. And lo and behold, the interval is from 0 to 6. 1 and 3 both fall inside that interval, so they're both candidates. And in fact, we have 4 candidates here, 0, 1, 3, and 6. So we're going to take those 4 candidates, and we're going to have to plug them into, remember, it's the original function. So we need r of 0, r of 1, r of 3, and r of 6. Now we're looking for the furthest to the left, all right, and well, that's your right on the screen, but the furthest to the left right here we see is going to be the smallest value. So in essence, we're looking for the absolute min here. We want to find the smallest of the 4 values. We start by plugging in 0. 0 is easy to do. 0 minus 0 plus 0 plus 3, so we got a 3 right there. Okay, now we plug in 1, and we have 1 minus 6 plus 9 plus 3. 1 minus 6 is negative 5, plus 9 is 4, 4 plus 3 is 7. Okay, now we have to plug in 3, so things get a little trickier now. We're going to go to the calculator. That's fine. 3 cubed is 27, and 3 squared is 9. 6 times 9 is 54. 27 minus 54 is negative 27. But then right away we add 27, so we're back to 0, and then we add 3 more, so r of 3 is also 3. Okay? And finally we have to plug in 6. 6 cubed, I'm sure you're up to date on your cubes table. 6 cubed is 216. This is also 6 cubed. It's 6 times 6 squared, which is 6 cubed. So this wipes out to 0. Then we add 54, but then we add 3 more, so we're at 57. Okay, so we're interested in the furthest to the left, and it actually occurs twice. The furthest to the left is 3. And it's okay that it happens more than once. There's no rule that says there can only be one occurrence of the absolute minimum value. We just want to know what is the absolute minimum value. In this case, what is the furthest point to the left? What's the furthest, the leftmost x-coordinate? And in this case, it's a 3. It happens twice. So our particle starts, it goes out, it goes back, and then it goes out again. That's basically what happened. But we answered our question. The furthest point to the left is, if you will, x equals 3. That's our x-coordinate.